you are planning, whenever you are planning a research study, especially a funded study in a medical research, the important question is how many participant on observation will be educate for your study to answer the research question. So this is the first question come into the mind when you are going to be planning a study. You all face this type of experience when you are going for the MD student for the writing the protocol and some PhD thesis protocol. So the first question come into the mind, how many sample size we will educate to answer this our hypothesis. So nowadays some journals also provide the mandatory for the sample size justification, and they also it is available in the checklist of the journal submission whether you have calculated the sample size or not, or you have to give the some justification for the sample size. If you are not calculating sample size, so you have to give the some justification. So the sample size is based on the two type of approaches. First approaches is the precision approach. In that approach, we not compare to the any group, we just estimate that one. Doctors, that Saraswati is doing something, I think, Dr. Dharmender. So
all the participants kindly don't disturb in the meanwhile, otherwise we will remove you. So you will not be able to join the session.
So there are two approaches. First is the precision approach and other is the hypothesis approach. To answer this question, the investigator requires some statistical reasoning as well as the informed guesswork. So you need some statistical background for the finding out.
Sir, you are on the first slide. So are you explaining only or?
I am telling, just I am giving the brief of the sample size.
Okay, sir. Okay.
I have not started my slide now. I am just giving some brief of the sample size and what we will do in all the 3 days, what topic we cover or what will topic we are not able to cover, and we will cover in our upcoming webinar for the sample size. So that is some brief background for that one. So now there is a lot of calculators are available in the digital world, and the researcher can determine the sample size. However, the correct input, the problem is that whether you are inputting the correct value or not, that is a big challenge for that one. So this webinar help you to find out, give some brief concept of that, and what precaution you have to take while you are calculating the sample size using the calculator, online calculators, and what precaution you have to take. So this we will explain this in webinar, the basic concept and the precautions. So this is not much mathematically, and this does not cover the situation where the sample size is calculation is quite complex. Like in RCT with non-inferiority trials and the equivalence trials, and then survival analysis outcome, repeated measure outcome, and there is some ROC curve. Or like this, we will cover in our next, that is a basic and beyond sample size calculation. Maybe the help, hopefully we will do in the next 2 or 3 months. So this present webinar be divided in the 3 session. And first session we are discuss about that. Today we will discuss about the covering of the precision sample size based approach, also known as a confidence level approach, usually calculated in the cross-sectional studies, and this is used for the estimation of prevalence, mean, correlation, and or the sensitivity specificity. Apart from this basic concept, we will go for some practical examples on using online calculators. And then tomorrow we will discuss about the hypothesis testing for the one sample and this with the specified literature value, and the two independent sample hypothesis test for the proportion of mean, correlation, and some under the various study design. And in the last day, we will learn about the sample size determination under the some pair designs, some rule of thumb for calculating the sample size, steps to reduce the sample size. If you have a large sample size, so what can you do to reduce the sample size, and the some frequently asked the questions and the practical example for them. So now I will start my presentation. This is the precision first. Today we will discuss about that. This precision research sample size determination with the examples. So these are the two online calculator. We are using two online calculator. You can download these two online calculator, and later we will I will explain how to work on this calculator. So this is on outline of this session that I already have explained, but there is some other topics are there. So first is the understanding of the statistical inference and importance of the sample size in medical research. So we will discuss what is the statistical inference and how sample size is important in the medical studies. Then I will explain the normal distribution and its property. All you are aware about the normal distribution, but just to recap of this, I will explain the normal distribution. And after that, some brief of the sampling distribution, because sampling distribution have a major role in calculating the sample size, basic concept of that. And then what is the confidence interval and the common study design we use in the medical studies. And this is the sample size for observational studies. First, we will discuss about the core component for determining the sample size, and then for mean, estimation of proportion, sensitivity, specificity, and then various type of adjustment that need to the sample size. And lastly, I will give some introduction of online calculator. So this is the outline of today session. What is the statistical inference? Statistical inference is what? Why we calculate the sample size? First question in come, why not we do the all the population? Because population is infinite, so we draw the inference based on the sample size, sample. So that's why we need a sample size, adequate sample for the population. Population here means what is your target population. Target population, what if, for example, I say if you are want to calculate the prevalence of the diabetic in the adult subjects. So adult subjects are your population, or there are the adolescent or children are exclusion criteria. So they are not, this inference is not applicable to that. So that is your target population. So you must define your target population before going for the calculation of the sample size. So in statistical, first we define some population, then we calculate the sample form, draw the sample, and do the some hypothesis, whatever our aim for the study is there, some modeling or the whatever the conclusion we draw, then we inference to that target population. So this is the cycle of the statistical inference. So first we define target population, then draw the sample, and then we go for the hypothesis, like interview I want to observation study is just observing that, or interventional you are doing. Based on the calculation, you again go back to your target population for inferencing what are the results is there. So that is the whole cycle of statistical inference. Now I come to what is the importance of the sample size determination in the empirical research. So first main issue is that there are ethical issues. Whenever you are planning a study, so that goes to the ethical committee, and ethical committee main is observe that whether you are calculated sample size is adequate or not. So that in conducting a study of an inadequate number, subject may be unethical because you are unnecessarily giving to the toxicity or some burden to the participant. So that is also underpower study failed to detect the desired results. On the other hand, overpowered. If you have taken the large sample size, that may lead to the wastage of the resources when a reliable calculation can be drawn from a smaller sample. So this is the ethical issue is that, and you have to write in protocol what is your adequate sample size, whether you have calculated or you have to justify the sample size. This sample size we are taking for your study, but why you are taking for this one. The other use for this sample size is cost. When you calculate the sample size, you can find out the what is the cost apart from the fixed cost, what is the variable cost. If there is a drug involved in that and there is some test involved, so that you have to find out what will be the my cost involved in this study. Because if you don't have a sample size, in that case, you cannot calculate the estimate of the cost for the you are going to be spent in the to the participant, or what are the on the patient for your research. And third point is that is time. Because if you don't have a sample size, then there is a difficult to calculate the time duration of the study. So this will be help in the duration of calculating the duration of the study, especially in the survival time to event outcome. Okay, because initially we don't know how much sample size, how much time will we take. So if we have a sample size, then we can calculate the time on the base of our experience. What are the some participant per month is available, then how much sample size I can complete in the that duration, 1 year, 2 year, or 3 year. So that is the time is a main important point is that for calculating the after you have a sample size in your hand. The last is the feasible. Second last is the feasibility of the study. Feasibility of study. What is meaning of the feasibility study? You have calculated the sample size for your study based on the some previous guesses or previous literature values, and you find that the sample size is quite large, and that is not possible to do in present scenario. So that is not feasible. So what you do, you have to decrease the sample size, or you plan some other variable, other outcome variable. So this is the feasibility part is there, calculating the sample size and deciding the whether it is a feasible for your, you can do this study, or you have to choose some other option for reducing the sample size. Lastly is the reliability of the study. Reliability of the study means you have determined the sample size on the basis of scientific way. If you have calculated sample size basis on the scientific way, so if other person are doing the same study in the same target population, he will get the same result. So in that case, your study is reliable for that. So sample size, if you calculate the sample size properly, the calculated sample size are reliable. You can generalize your result to the target population, and the other researcher can get the same result. So your study is reliable for that. So these are the major 5 points. This is not an exhaustive list for that. There may be other benefits for the calculating of the sample size. So these are the 5 major benefit for calculating the sample size. Now, before this, going for the deep of the sample size formulas and all this, and first I will explain the what is the normal distribution, because all the sample size calculation are the based on the normal distribution. Or this is also called the Gaussian distribution. This is a symmetric distribution, and 1 plus minus SG that cover the 68.2% of the area. The total area is 1, and 1 plus minus 1 SG is cover the 68.2, and the plus minus 2 SG is cover the 95.48, and plus minus 3 SD is 99.7. So this is based on this normal distribution. We can calculate the probability of the area. What is the probability of area? So these are some characteristics of the normal distribution. That is has a bell shape, curve, and symmetric. It is symmetric around the mean. There is a center point. Mean is a center point. And one of the property of the mean is that mean, median, and mode are equal for the normal distribution. and the total area curve is 100%. The normal distribution has a shape of the standard normal. There is a standard normal distribution with a zero mean and standard deviation is 1. If we standardize this normal distribution, we can convert into the standard normal distribution that is a zero mean and standard deviation is 1. So these are the properties of the normal distribution. We will use this normal distribution in our calculating of the sample size. Now, that is a sampling distribution. Before I go for the sample size formula and all these things, I will try to explain the sampling distribution, how we go for the sample size calculation. So in sampling distribution as name, what name is suggesting? Sampling distribution. That means distribution of sample. This is distribution of sample, not the distribution of participant. So you have to keep in mind, this is the distribution of sample. What is the meaning of distribution? Distribution is that if you are taking the 100 subjects and plot in the various value and pictorially plot, so this type of graph is called a distribution. So this sampling distribution means distribution of samples. That is your must care about that sampling distribution. So what we do in that for calculating the sample size, we first find out the sampling distribution, and sample distribution is normally Gaussian distribution. How we do the sample, how we create the sampling distribution? This is, I am taking the one example is that our total, this is a population distribution. I have a two color of that, blue color or red color, and those are the proper, this is 50-50%. They are both are equal. So in that case, well, I draw this is my target population for inference, drawing the inference. I draw a sample with a random sampling and then I calculate the blue and red. I got the proportion is in this sample is 0.40. So this is not 0.5, but it is a 40. Then this is all hypothetically we are doing. Then go for the second sample and we found that there is a blue and red proportion is, blue proportion you can say that is a 55%. So if I go for that, similarly I repeatedly draw the samples. Suppose I draw the 1000 samples of 100 subjects or 100 colors in that. So what is that? I have a 1000 proportions are with me. Now this is the 1000 proportion I value. Some value is 0.4, some value is 0.5, some value is 0.6, some value is 0.7. So for that 1000, I draw this distribution. So this distribution is showing the 0.5 is a midpoint, and all the distributions are proportion values are in the left side or the right side of it. So this is called a proposed sampling distribution of proportion. Now, when we calculate the sampling distribution of proportion, then we calculate the standard deviation of samples. This is the standard deviation of sample. This is also known as a standard error. How we calculate the standard error or standard deviation of proportion in the sampling distribution? This is the formula for this one. That is equal, that is equal to pi multiplied by 1 minus pi divided by n. So this is the standard deviation of sampling proportion, sampling distribution proportion. This is also called the standard error of proportion. That. So in this distribution, we find out the 95% confidence interval. 95% confidence interval I explained in the normal distribution that if we cover the 2 SD either the side, so we cover the 95.4. But if we multiply by 1.96, so we cover the 95% of the area. So in that case, we calculate the 95% confidence interval to find out what is our range of the proportion. In that case, we are 95% confident that our range will be varies into this to this. I will explain the confidence interval. There is a two definition in the later slides. So, but for the layman, that is what is the confidence interval? Confidence interval is that in that case, what is the range in which Y true population will estimate will lie. So this is for the binary value. Now same thing we can calculate for finding out the mean sampling distribution. So this is my population distribution, that is the mu, and standard deviation is, I have taken the rho is standard deviation. Similarly, I draw the 1000 sample of 100 subjects from this population and draw the distribution for that. This is also a normal distribution, and my mean normal distribution mean is a sampling distribution mean is that is denoted by the x bar, and there is standard error is equal to rho by square root of n. This is wrong thing. This is correct. 1.96 multiplied by standard deviation divided by square root of n. So this standard, you have to take care about that. This standard deviation is for the single mean, and this is standard deviation divided by square root of 1. Our standard error, that is the standard deviation of population mean. This is for the mean, standard deviation of mean. There is a difference between the standard deviation or the standard error. So this is standard deviation is this is the standard error. Standard error is standard deviation divided by square root of n, or you can say it is a standard deviation of mean. What is the standard deviation of mean? What we are plotting the 1000 sample of 100 subjects, and so we have a 1000 mean is there, and this mean is a mean of 1000 means, and this is the standard deviation of 1000 mean, or in other words, we can say that the standard error of mean. So these points you have to remember this. What is the sampling distribution for that one? Hope you are, maybe I am able to explain this one. Now I will, same thing I will try to explain in the taking a practical example for this one, for sampling distribution, because the sampling distribution is the main thing to understand the sample size. If you understand this concept, then you are easily understand the basic, what is the basic behind the concept of the sample size. So I am just explaining a practical example for this one. Same thing I am repeating here. For this is the, for the Indian statistic publication, publish a report. The Indian statistics publish a report saying that 52% of baby born in Delhi are the male. So they publish a report in saying the male population born birth rate is 52%. This percentage was determined by considering all the babies during the 1 year. The question is that this is our target population. This 52% we don't know. This you remember that this is, I have given for the just example, but this 52 is normally not known to you. This is just a guesswork we find out, and we calculate by drawing the sample. So the question is that how precisely I can estimate male percentage, determine the sample of the 100 births. So instead of taking all births, if I take the 100 births, can I estimate that male baby born is around the 52%? So this is the question is that. So 52, I am again repeating, the 52 is our not known to us. We just find out by the guesswork. This is the guesswork. What is our estimated prevalence rate? In sample size calculation, we can find out from the previous literature what is your estimated prevalence rate. So here I am just for the your explaining this. 52 is our target population mean, that is given. And how much sample size, how precisely I estimate the male percentage can be estimated if I take the 100 births. Can I estimate the sample size of the 52? What are the margin of error is there? So I take a sample of the 100 births. The boy percentage was found to be 54. I draw the 100 sample and I calculate the sample size of the birth boys and find out it is 54%. So can I say it is 52? So that is a nearby this one. So we can say that is we are closer to the 52. I will explain also the what is now the role of the confidence interval and the margin of error. This can be estimate for the Delhi population. Another sample I draw that one and found it is 53. Similarly, I found the 20,000 number of samples from 100 birth, 100 subject, 20,000 I draw from the target population. So what is, I have a 20,000 percentages with me that I plot in this histogram and found that this is my normal distribution and this shows the frequency of 20,000. How much is if I take 52%, 52% is how much? That is 1,500 that. So this is my histogram plot. It is showing that is normal distribution. So I can find out what range is what is the confidence interval is that for estimating the 52 as my target proportion. So the distribution of the boy are called this is called a sampling distribution, and the 95% confidence interval. Now in the second graph, this graph you find that a normal, I calculate this 95% confidence interval. So based on this 20,000, I find confidence interval that this is equal to, based on the 100 sample, the 95% confidence that the boy, 95 confidence in 62 to 63. Sorry, 42 to 62 is that. So on base, this is based on the 100 sample. So I have written wrong with that one. Based on the 100 sample, we are 95% confident that the range of the boy percentage is 42% to 62%. So this is our range is that instead of 52, we are a range is 52% and 62%, and this point proportion is my 52%. This is based on the 100 sample. So that you see that there is a wide range. There is a wide range, 42% to 62%. Then what we have an option, I can increase my sample for the 500 subjects. So I increase my sample for the, instead of 100 sample, I increase to the 500 sample. In that case, my confidence interval will be 97.6 to 56.4. So that is a narrow range, and that this 52% is covering in this one. Okay. So this is the behind of all the things. If you take the small sample, your confidence interval is wide. If you take the large sample, your confidence interval is narrow. So now what you do? Then you have to find the optimal solution, optimal sample size. And optimal sample size, how? We can find out by the formula using the normal distribution. So this is the basic behind of the calculation of the sample size based on the sampling distribution. So this is I think theoretical part of that sample size calculation. I think you understand. If you have any query, you can write in the chat box. I will try to explain. Now, what is the meaning of the confidence interval? So there is some confusion regarding the confidence interval. What is the meaning of the confidence interval? So I first try to explain what is the meaning of the confidence interval. Now, confidence interval is that interval. If you see that example, this is the sampling distribution. Again, the sampling distribution. Now you understand what is the sampling distribution. So in sampling distribution, this is our true mean. True mean, we say what is the target mean that we don't know. We have to estimate. If we already know, then there is no need for going for the study. We have to estimate from our sample and inference to the target population. This is the aim for this one. So this is, we don't know. We have our guesswork for this one. Our guesswork, I will explain what are the procedure for finding this guesswork in the later slides. So now again, we have to take there is a lot of samples we are drawing for finding out the sample distribution. For each sample, we find that a 95% confidence interval. So if you are taking the 100 samples, so in that case, you have a 100 confidence interval. So your confidence intervals are varying, but your target population are fixed. That you remember that what are your target population you are to assuming that is fixed, which is not varying, and your sample is varying, or you are calculating the sample size for the calculating the confidence interval for the 100 samples. So each sample has a confidence interval. So what is the definition of the confidence interval is confidence interval means a procedure repeated on numerous samples, and you draw the this one sampling distribution. The proportion of calculated 95% confidence interval encompass the true value of population parameter would tend towards the 95%. So in that case, if I have a 195% confidence intervals, so I am sure in the 95 times that my true population will lie in this confidence interval. So this is the actual definition. But there is another definition, which is that the confidence interval can be expressed in the, if you are taking one sample, this is also can be expressed in the this form. Confidence interval can be expressed in the probability concerning a single theoretical sample. If you are taking one sample, there is a 95% probability that 95% confidence interval given from a future sample will cover the true value of population parameter. That means I am 95% confident that whatever the confidence interval I am getting from the sample, this sample, that my true population will cover in the 95% with probability. So this is the definition of the confidence interval. So you have to make clear that what is the meaning of the confidence interval, and confidence interval, how we calculate the confidence interval. So confidence interval is equal to the point estimate. That is, point estimate is what is my if I take the 100 this one 100 samples and 100. So I have 100 means are there, 95% confidence intervals is there. So this is the mean of 100 means. That is called a point estimate, plus minus z minus 1 minus alpha by 2. Z is a standard normal deviate, and 1 minus alpha by 2. Alpha is my confidence level. Is there? If you have taken the 95% confidence interval, that means alpha is equal to 5%, or because I have alpha by divided by 2, why I divided? Because I have taken the two-sided here. The confidence interval is 95 is this, 2.5 is left side, 2.5 is right side. So that is total is 5% is that. So that is multiplied by standard error. So keep in mind that that is why you are taking the alpha by 2. I will explain in hypothesis testing. If you are going for the one-sided, then you can take only the alpha. So that is for this confidence interval this estimation, we use the two-sided confidence interval, two-sided alpha by 2. That is alpha by 2 left, alpha by 2 right. That is a 95% confidence level. This is the 95% confidence level. Now we come to the some study design. What are the commonly study design, and then what are the estimation scenario? What are my primary outcomes are there? So first is the cross-sectional study. That is, we are going to be discussing here in the for sample size, for prevalence, and this one. That is expected prevalence and margin error of estimation. So in that case, in cross-sectional study, we generally find out the what is the prevalence estimate. Another is we can also find out for the hypothesis also, when comparing the prevalence in the both the groups, and the correlation studies are there. So suppose we are finding out the correlation between the two variables. So in that case, we are study design is correlation, and our primary outcome or our estimation scenario is that is the precision, Spearman correlation or precision correlation, Pearson correlation. So this is first is a cross-sectional design, and other is a case control design. What is the case control design? Case control design is this is from the outcome direction. These are the direction is in cross-sectional. Either the direction is that you don't know about the exposure, or you don't know about the outcome. So in the same point of time, you are finding out both the outcome and your exposure also. Now we come to the case control style. Case control design is the direction is that outcome to exposure. First, we have a outcome. We know about the what is the case and what are the corresponding controls are there, and we go for the what are the exposure proportion are there. So in that case, we calculate the compare by using the odd ratios or compare by the proportion in case controls. So that is the in the case control studies we are going to be do for the calculation of the sample size. Now, third is type is a cohort study. Cohort study, what with direction is that correct cohort study, the direction is from the exposure to the outcome. We know the exposure and we go for the finding the outcome. For example, you are going to take this, you are studying the smoker and non-smoker and find out for the 5 year, you then find out what is the lung cancer is there or lung cancer is not there. So in that case, exposure to outcome. First, we have a exposure with you and you are going to be measure the outcome. This is the match study. Another type of this is the match study. Case control match studies are there. In case control, there is a drawback is there. A lot of confoundings are there. So removing the confounding, what we do, we match the case control for the confounding factors. Or there are some other type of studies before and after. I take the one group for the before and then give the treatment and assess the after the treatment. So only taking the one group. So this is the before and after. So I will explain in last day what is the how to calculate the sample size for the match studies period. Then we go for the diagnostic study. Diagnostic study is that we are finding out the what are the diagnostic method, finding out the what is the diagnostic accuracy of the new method in comparison to the existing controls for that one. That is a gold standard for that. For example, histopathology is a biopsy. Histopathology is must gold standard for the diagnosing of the cancer. So that is our gold standard, and new techniques, we are new biomarker we are using or new method we are you finding out to find out whether we can avoid the biopsy and that have a same sensitivity and specificity and PPV, NPV. So like this in the diagnostic study, we are finding out that. Then there is a randomized control trial. Randomized control trial, all you know that we randomize the two in the parallel design in the two groups. We randomize the subjects and then one we will give that standard treatment, another we give the new treatment and then find out the difference for that. So this is the randomized control trial. So we are not covering in the randomized control here. We will cover in the next, I think, our advanced sample size calculation, how to calculate the sample size for the randomized control trial. Then there is an agreement study. Agreement study, there is another type of study, is that agreement study. You are nowadays, what is that? There is a lot of questions are forms are coming, the scoring methods. There are pain scoring method, the quality of life scoring method. There are a lot of method the scoring system are covering. That is a subjective scoring system is there. So in that case, what is that? We have to find whether this is the agreement is with the retest agreement for this one. First we give that subject to the pain score, and after that, after one that in quality of life for the next day, we again give the and then find out whether there is a changes is there. So that is agreement state. Another type of agreement is that we are finding out that like in my mercury method for the measuring the blood pressure to the digital. So they are measuring the blood pressure. In agreement study, we are measuring the same outcome. Like in blood pressure, we are using the two methods for this one. In the radiology, we are finding the X-ray finding. We are comparing the outcome from the X-ray versus ultrasound or ultrasound versus CT. So in that case, there is called agreement studies for that. This is usually applicable in most I found in the radiology and also in the dentistry of that. So there are a lot of application for the agreement study. Lastly is the time to event. That is a survival analysis, and that is applicable in the cancer studies. We recruit the patient and then we follow up for the some period of time and then find out whether they are overall survival, disease-free survival, progression-free survival, disease-free survival. So these are also we are not covering here. We will cover in later webinar. So this present webinar, I will cover the cross-sectional, case control, cohort study, match study, diagnostic study, and agreement study, some part of the agreement for the interclass correlation and kappa statistics. So this top such study design we are covering in this webinar. Now, this is up to these slides are some basic background of the sample size. Hope now you understand some basic behind the sample size. Now we go for the sample size calculation in the uh, actual sample size calculation using this formulas for the thing. So this curve is showing that some relationship between the sample size and reliability. To rely at you can see that there is an increase in the sample size and reliability is also increasing. That is also true that in the sample size increasing, the reliability of the study is increasing. But we have to find out some sample size as an optimal sample size so that our reliability is also in a good, not bad. Uh, I will explain if you take the small sample size, then that is easy to do. You can easy to find out quality is good, but problem is here that is here reliability is not good. Reliability means that you can, if you another person can do repeat that study, so he may or may not get the same result for that. So in that case, reliability is your study reliability is not good for that. If you are taking the too much large sample size, then your reliability is good, but that is hard to execute. Hard to execute means if you are taking that 50,000 sample size, so it will take time, it will involve the cost also, or some toxicity also you are given for this one unnecessary. That so that is also another is the data quality is missing values are there. So that is the part for the large sample size. So we have to find out some optimal way to find out our reliability is also good, and we can do the our study or get the our hypothesis results with a good power. So this is graph explain that the relationship between the sample size and reliability. So now we come to the statistical inference for the sample size. There are two type of sample size inference. First is the estimation and the second is the hypothesis testing. What is the meaning of the estimation and what is the meaning of hypothesis testing? Estimation, what mean you are estimating some parameter value. That means, for example, you are estimating the proportion of diabetic in a population. So you are estimating a diabetic population. What is the proportion of diabetic in this group? You are not comparing with the another group. If you are comparing the proportion of diabetic in the male and female or adult and old, in that case, there is a hypothesis testing because you are comparing, you are making some hypothesis whether they are equal, they are unequal, one is greater than other. So in that case, you are making hypothesis. In estimation, you are not making hypothesis, just you are estimating the parameter value with a confidence. What will be the value of mine that I have explained in the this one sampling distribution, that is 52% my boy percentage is there, and I want to estimate whether through the sample whether the how much sample is required for getting this 52% with some precision level. So this is called estimation for that. So in first lecture today only I will explain the estimation. Tomorrow I will cover up the hypothesis testing. So these are the some example. I am taking the hypothesis testing. For example, suppose estimation of the proportion of delirium in the palliative care patient. So we are finding out the what are the proportion those who are patient are in the palliative care OPD. What are the proportion of the delirium? So these are just estimation. On the other hand, if you convert the study to the compare the proportion of the delirium in the cancer and non-cancer palliative care. Here we are divided into the two group, cancer palliative care patient and non-cancer palliative care patient, and find out what is the proportion is significantly different or not in cancer. Or here hypothesis that in cancer patient delirium population is more than non-palliative non-cancer patient, or have a less proportion of delirium in cancer patient as compared to the non-cancer palliative care. So here we are making some hypothesis testing for this one. Second example I am taking that is the estimation of proportion of neuropathic pain among the cancer patient using some pain scale. So I am estimating what is the neuropathic pain in the cancer patient using this is the scale, NANSS scale we are using to find out whether the patient has a neuropathic pain or not. This is called estimation. And on the other hand, we can say the compare of the proportion of the neuropathic pain in the cancer and the diabetic patient using this scale. Now we have made the two groups, cancer patient and the non-cancer diabetic patient. Now, cancer diabetic may included, but cancer and diabetic, that is not cancer patient. Or on other way, say you can also find out whether the cancer patient non-diabetic and cancer patient diabetic pain. So like this, we are making the hypothesis testing. If you are doing this, so you have to make the hypothesis. If you are estimating, then you don't go for the type 1, type 2 error that I will explain tomorrow for this. What is the type 1, type 2 error are there. But first, what is your aims and objective? That's why when you go for the sample size calculation, so I will generally ask the 2 or 3 questions. What is your aims and objective? What you want to do that one? So if you are comparing some say ki I am comparing that one, or some going to RCT, if you are say the RCT, that is comparison, making hypothesis. But if say ki I am doing that one for finding out this one diabetic proportion and find out the risk factor for the diabetic. So in that case, we are finding out the estimation. So that you have to take care ki what is your aims for study for that. So these are the prerequisite determination for the sample size for estimation of a parameter. So that prerequisite requisites are the key factors are there. First, you have to choose your outcome. Outcome, what is meaning of the outcome? What are your outcome is there? For example, you are making the outcome for the proportion of diabetic. That is called the dichotomous outcome. Or you have a ordinal outcome is there, or you have a continuous outcome is there. So there are the 3 type of outcome are there. Outcome, what is the scale of outcome is there. So first you have to decide for that one. You are taking categorical outcome, you are taking the continuous outcome, and what is your target population this. So target population, I have explained what is you are going to inference your result, that is called your target population is that. If you are taking only the cancer patient for it, so that result is applicable for the cancer patient. If you are neuropathic pain in cancer patient, so whatever your results are getting, that is applicable to the cancer patient, that is not applicable to the non-cancer patient. You have to take in mind this one. So this is the target population for that. Second thing is that you have to know about the variability. Variability is meant what is the uncertainty in that. That variability is measured in case of continuous by standard deviation, and if you are qualitative data, then you calculate from the proportion that I have given the same formula for this one, that you can find out that variability proportion for qualitative data. So how you get this one? Because this you don't know prior to the study. This can be obtained from the previous study or from the pilot study or some expert opinion. So this information you can get from these 3 sources of that. Previous study, if you are going for the previous study, so you have to keep in mind whether this study results are applicable to my population or not. For example, I calculate the proportion or something prevalence of diabetic in Delhi, or I am taking the prevalence for sample size calculation prevalence from USA. So that is not applicable here. You may not get a reliable result or educate estimation for that. So if you are taking the previous study, so previous study may be relevant to your population. If the outcome is varying from the is affected by your population. Another you can find out from the pilot study, or you that is the some robust method is you have to find out the your standard deviation doing the pilot study, because pilot study is you are doing in your hospital or in your region. But in pilot study, you have to take care. One thing you have to take care, you do the pilot study in the same way where you are going to be, same way as you are going to do in the your main study. In pilot study, just you calculate the sample size, 10 patient, and then do that one, calculate the standard deviation. But you have to take care, the pilot study is a similar to that scenario. What are the scenario is there that should be matches with your main study. In that case, your pilot study is robust. Another is that expert opinion. Expert opinion is that what is the area of the expert. You can find out if you are finding the diabetic prevalence, you can find out the good endocrinologist person to what are the expected proportion of that. So these are the some method for finding out that variability. Next is the minimum degree of precision required, or that is margin of error. What is the meaning of the margin of error? Margin of error is that you are estimating the point estimated, that is in sampling distribution, you find that is a 52%, but it is not finding the exactly in all the sample 52%. So there are the some ranges there. So we found how much accepted margin of error, how much error I can bear in estimating the target population. For example, 52, I can bear only the 5% either the side. That means if the 47 to 57 is okay with me, I can bear the 5% margin of error. So this is the called the margin of error. And fourth is confidence level of estimation. Usually we take the 95% confidence level, but it can be increased to the 99 if you are more finding out the more precise estimates. So this is the formula for calculating the sample size for the estimation. This is the some common formula for sample size is equal to variability square. Variability is standard deviation square multiply by Z confidence level. Confidence level may be 95%, 99%. These are the values. 99%, if you are taking 99%, either the side, your value is 2.58. If you are taking the 95%, your value is 1.96. Or if you are taking 90%, your value is 1.645. So these are the confidence level, and this is the value of your Z minus 1 by Z minus alpha by 2. So as confidence level is increasing, you say the Z value is also increasing. That is divided by the margin of error square. What are the margin of error you are taking? That square you will square this. This formula you apply in finding out the estimation for this, either mean or proportion or correlation or sensitivity, specificity, the all thing in the estimation. This is the main formula for that. Now there are some adjustments are there. So what is the subgroup? Subgroup, what meaning of the subgroup is that? In subgroup, if we are going to find out the prevalence of the diabetic, in that case, there may be variation of the diabetic in male, female, and adult and old patient. So if we are taking the all patients, so there is a more heterogeneity. So what meaning of the subgroup? We avoid the heterogeneity. So we divide into the subgroup in that. If you have a subgroup in the, so accordingly you have to adjust this. How to that one? You calculate the sample size for the all the subgroup, and if you are taking male female, then you calculate the for separately for the male and separately for the female, and that total sample size you will take for the your study. Another is that estimation of non-response. When you are going to be survey or some form, your quality of life form or some form is filling. So yeah, ethically you have to convince the patient you should be involved in the, you are involved in the study. So some patient may involve, some patient may say refuse for that. So in that case, there is a estimation of non-responses there. That is in estimation. Some hypothesis testing also, some patients say, some if the longitudinal studies are there, some lost to follow up. So that is another part. But in the survey, there is a non-responses that those who are not agree for the participate in the study, that is called a non-estimation, estimation of non-response. And another is the multiple outcome of interest. If you have a multiple outcome of interest, if you are going to be do a survey and then you find out that I will calculate the proportion of the prevalence of diabetic also, I will for the same way I am going to find out the prevalence of hypertension also, and I am from going to find out in the cardiovascular CAV also or CAD also. So there are the some multiple outcome in the same survey you are going to find out. So in that case, if you have a multiple outcome of interest, so what we have to do, that I will explain in the later in that. There is a how adjustment for the non-response also, multiple outcome also. But in brief, you have to calculate the sample size for the each of the outcome of interest and the maximum of sample size you have to take. So this is one of the practical example I am taking for the estimation for your better understanding. A researcher wish to estimate a proportion of delirium in palliative care patient in a hospital. So a researcher want that what is the proportion of delirium in palliative care in my hospital. So in that case, a previous study reported that we find out a previous study that report the proportion of delirium in palliative care patient is around to be 40%. So that is my target population is that I have to estimate, but this is unknown because our objective is to estimate the proportion of delirium. So from the previous study, I expected that it is a 40%. And how much sample size would be needed with a margin of error of 8%. Now, in that case, I select the 8% margin of error. I can bear 8% if it is 32 to 48%. Then I say ki I am agree with this 38% to 48% for accepting the 8% margin of error with 95% confidence level. So these are the information available with you, and you find out the calculation how much sample size is needed. So in that, we have a two type of margin of error calculation. One is called the absolute margin of error. Another is called the relative margin of error. So in that case, absolute is that you calculate 8%, and that is your divide, subtract and add, that is 32% for or 48%. In relative precision, what is the relative precision? In relative precision, we use K percentage of standard proportion. I use K percentage of standard proportion. That is, for example, 25% relative margin of error in anticipated proportion of 40%. So that for 25% of 40 or in 1/4 of 40 is my margin of error. In that case, my anticipated proportion would lie with 30% to 50%. Or in other way, I say ki I have taken 10% absolute margin of error. So this you have to take care while you are using absolute margin of error or you are using the relative margin of error, because this is important in the giving the value in online calculator. Some calculator ask for the margin of error, absolute error, and some calculator ask for the relative precision, relative margin of error. So if you give the wrong margin of error, absolute in relative precision, you get the incorrect sample size. So this thing you have to take care whether you are giving absolute or whether you are giving relative. So this is another thing is that relative precision is useful when anticipated proportion is small. When we use the relative precision, the question is that the absolute is there, relative is there. So why we go for the relative? Yeah, we take the absolute. In relative precision is usually helpful when your anticipated proportion is small. For example, I say the anticipated proportion of 6%. And if I take the absolute precision 5%, so my range is quite high, 1% to 11%. On the other hand, if we convert into the relative precision of 5%, that is equal to 5% of 6.03%. And my range is 5.7 to the 6.3. So in that case, you have to understand the difference of the relative and absolute precision. Now we come to the actual sample size calculation. To estimate the population proportion, same thing. This is I am showing the sampling distribution, and I have to estimate this proportion, and these are my standard error. Or if I multiply by Z alpha by 2 with standard error, this is called the margin of error. So this is margin of error left side. If we apply point estimate minus margin of error, point estimate plus minus margin of error, so that covers the 95%, because I am calculating here the 95% confidence. The alpha is equal to 2. Alpha is 5 by 2. So this formula I convert that margin of error. Margin of error is equal to Z minus 1, Z 1 minus alpha by 2 multiplied by standard error of this one proportion. If I convert into the squaring both the side and convert into this form, that n is equal to Z square 1 minus alpha by 2 multiply by pi multiply by 1 minus pi divided by L square. So this is my formula for calculating the proportion for the or prevalence for a estimate for the prevalence. So margin of error, L is margin of error, is also called the precision, and can be small as need by the simply increasing the sample size. So if now we have three things for the calculating of the sample size. One is equal to confidence interval, another is my estimated proportion, and third is a margin of error. So from this I can find out this is the numerator, this is the denominator. If I increase this confidence level, my sample size will increase. If I increase my proportion, then I will explain what is the effect of that in the next slide. But if you increase your margin of error, your sample size will less. If you decrease your margin of error, then sample size is more. So in that case, you have to take care about that. For what parameter, if I change, my sample size will increase or my sample size will decrease for that one. This is helpful in the finding the online calculator. Okay, because if you change that values, so if you already know my sample size will decrease, so whether it is decreasing or not, so if it is increasing, that means you have given some wrong information. So you must understand what are the factor of that and what factor influencing the sample size. Now, for this a practical example is this one. A researcher wished to estimate the prevalence of diabetic in age of greater than 40 years in a Delhi urban population. A previous study reported that the prevalence is around 40%. Aim for an absolute margin of error is 5% on either the side. with 95% confidence level, how much sample size is needed? This is my question is that. Now, how we calculate the sample size? This is previously I have given the formula for this one. N is equal to Z alpha by 2 multiply by pi multiply by 1 minus pi divided by margin of error. So my value of Z alpha by 2 is 1.96. You can see that for the 95% Z alpha is equal to 1.96. I put here the 1.96 square multiply by 0.4 multiply by 1 minus 0.4 divided by 0.05 square. So if I calculate this, my sample size will come to be 369 subjects. So thus 369 subjects are required for 95% confidence with a margin of error less than 5% in estimating a population parameter, somewhere 35 to 45. So what is that? I am estimating this target population 40%. I am taking the margin of error 5%. So my margin of error 35 varies from the 0.35 to 0.45. In that case, how much sample size I will need? If I increase this margin of error, the sample size will decrease. So, or if I increase my confidence level, the sample size will increase from the, if I increase the confidence level from 95 to 99%, so you see that this is almost double the sample size of this. Or if you reduce to the 90, that this is quite less. As you are increasing the sample size, confidence level, there is a increase in the sample size for this one. So that you have to keep in mind. Now, this is the sample size for the proportion. Now we come to the sample size for the anticipated mean. In case somehow we find out the mean estimation. A mean estimation is that I am taking this example. A survey is planned to estimate the average level of fasting glucose in healthy females 40 to 80. My aim is to find out what is the average glucose level in 40 to 80 female healthy subjects. This is my objective for that aim. Then I go for the previous study. Now, if you see what is the aim is my finding out the average glucose level. The outcome is continuous outcome, average glucose level. My target population is that is 40 to 60 healthy females. This is my target population. Now, then we find out what is the variance of that. It is desired that estimated would be within 1.2 mg per deciliter of the population mean with a probability of 95%. So this is my margin of error, 1.2. And he can find that the previous studies, the standard deviation is equal to 6.3. So this is my variability. This is my margin of error, and I am taking 95%. So three things are required for estimating. What is the standard deviation? What is your margin of error? And what is your confidence level is there? Then how big a sample size is required? This is the formula for the continuous variable. You apply n is equal to 1.96. Same thing. This is the z value. This is the standard deviation 6.3 divided by 1.2. This is the margin of error. I got the sample size is equal to 106 subjects. So same in the proportion also, same in the mean also, the formula is same. But here the difference is that that is a binary or here we are using the continuous variable. So if the confidence interval raised to the 99%, that same rest of the parameters are same. My sample size will increase 184. And if I decrease the standard deviation and rest of the parameters are same, my sample size is decrease from the 106 to 16. So you can find out that how much change in the variation in the sample size from the standard deviation. If you decrease the standard deviation, there is sample size is majorly changed. So that is your main factor for that one, except for the margin error also. But this margin of error decision is your decision. You have to take your decision. I will explain how you will take that one. But the standard deviation you are taking, that you have to take from the previous studies, or going for the pilot study, or some expert opinion is that. So this is should be accurate for finding out the sample size. If you are not, this is not accurate, you are not able to find the estimated value of your target population. Now, on the other hand, I will explain this formula on if the resource permit specify n. Now, what is that? We have calculated sample size, but somehow we say ki I can calculate, I have to do only the 30 sample I can do. So in that case, due to the source limitation and some other part, so what is the my value of the margin of error? How much margin of error I have to increase so that 30 is sufficient to get? So in that case, margin error increase from the 1.2 to 2.3. If you are increase your margin of error from 1.2 to 2.3, in that case, your sample size is 30 is sufficient. But the question is that whether this 2.3 margin of error, you are acceptable for this one. If you are take 2.3, that you get the large confidence interval and your study is not much reliable for this one. So that you have to take care about that, whether if you bear 2.3 or it is that sufficient. In that case, 30 is, you can take the 30. So this is the some reverse calculation for that one. Another calculation, I say what is the confidence level. If I say the 30 subject, so or same margin of error, what is my confidence level? Instead of 95% confidence, how much confidence level is my confidence level is decrease. So that is, I calculate by this one, reversing this formula and find out that there is a 70% confidence level instead of 95%, 75% confidence level. So these are the some method for the reverse calculation for this. Generally, we don't recommend it this one, but if you are want to find out, so in that case, you can find out in the estimation, but in hypothesis testing, reverse calculation is not accepted. That tomorrow I will explain why this is not accepted. But here you can find out what my confidence level is there. So this up to the finding out the proportion and the mean. Now we come to the what are the some technicality problems in finding out the proportion and also in the mean. Some scenarios are there. So I will discuss that. Question is that what is the appropriate precision or the margin of error for the prevalence study? Now, when you go to the statistician and say, this is the my prevalence is there. Then he will ask the what is your error is acceptable. So this is a general rule of thumb. This is not mandatory you will take, but this is the general rule of thumb is that if your disease is 20% to 80%, expected proportion is lying 20% to 80% or 10% to 90% also in between, then you can take a margin of error of 5%. That is a rule of thumb. But not this is the decision is by the researcher or researcher PI or some other expert person can take for the what is the margin of error is there. But generally rule of thumb is that if you're 20% to 80%, in that case 5% generally we take them. 5% margin of error, that if you are taking 5% margin of error, then what is the your interval width of 95%? That is a double of that. Interval width is 10%. There is a relationship between the margin of error and the width of 95% confidence interval, that is double of that. So some calculators that why I am showing this one. Some calculator ask for the margin of error, either the side. Some calculator wants the what is the interval width. So if we are asking for the interval width, then you have to give the 10%. If they are asking for the margin of error, then you have to give 5%. So this for while you are doing the digital calculator, so these things you have to take care about that. If we are taking this one 30 to 40% or 60 to 70% for the, if my true prevalence is 35% and the margin of error is 5%, then my confidence interval is 30 to 40% or 65%, then 60 to 75%. So in that case, why I'm now margin of error 5%. Now I am explaining you what is the reason behind that work. If you are 10% or 90%, why you not take 5%? So this is, I explain why in the one example. If you have, say the prevalence is 2% in the rare disease, then the choice of margin is error is more critical. So due to the small prevalence, even a small margin of error can lead a significant relative difference. In this case, D is 1% might be sufficient necessary. That means if your prevalence is 2% and margin of error is 1%, that means there is a 50% margin of error you are taking. So in that case, you have to take care if the prevalence is rare, to how you will take the margin of error, so that should be educate. Now, this is for the estimate problem for the proportion, precision and the margin of error. Now we come to the estimating of proportion. What are the method for finding out the target population? That can be from the previous study, as already I have explained that one. For the doing the pilot study also, expert opinion. Nowadays, the meta-analysis is everywhere. You find the meta-analysis for the prevalence is also there. So that evidence base you can take the from the meta-analysis, what is the my proportion of that. So first I will explain this graph. What is the meaning of this graph? If your proportion, that is here is the proportion and this is the variance. Variance is this, that is the standard deviation for that. What is the uncertainty in that? You find out that from it start from the 0, variance is 0, and then it is come to the 1, it is 0. As your proportion increase up to the 0.5, there is variance is high from the 0.5, and then after 0.5 it is going to be decreased. So if you are proportion, you take the proportion 0.5, then what is your variance uncertainty is higher. Uncertainty is higher. In that case, your sample size is more as compared to if you take 4%. If you take 4% instead of 5%, then your sample size is less. And if you take 5%, 0.5%, 0.5, then your sample size is more. So if the proportion is 0.5, then your variance is more. So this graph, I am showing that as variance is increasing up to the 0.5, and then after that it is decreasing. What is the implication of this graph? For example, I find out from the previous literature, the target population is varying from the 22, but 20% to 30%. So now the question is what value I should take. Either take the 20% or I should take 25% or I take 30%. So generally it is recommended you take a 30%. What is the reason for taking the 30% instead of 20%? This is the reason is in the graph. If you take the 20% or 0.2, your variation is equal to 0.16. If you take the 30%, your variation is equal to 0.22, near about 0.22. In that case, your sample size is high. So generally it is recommended you take 30% so that your sample size will be higher for that. Similarly, if your range is a 60% to 80%, now the question is that I will take 60% or I will take 80%. So here again we go to this curve. In 60%, 0.6, if we say this is the standard deviation 0.24, if 0.8, then our variance is equal to 0.16. So it is recommended you take the 60%. So what is the decision for that? Whatever the value or range, if you have a range, that range, upper range, that is if it's closer to 50% or 0.5, you will take that value. Or another thing is that if you have any doubt, sometime is that there is no previous study, you cannot do the pilot study, expert opinion is also not available, that evidence-based meta-analysis also you are not able to find out. So what is the option? But here you have to take care that your proportion will be greater than 10% and lesser than 19%. This you have to find out what is my proportion is maybe 10% greater than 10%, maybe 12, 13, 14, but I don't know what is the expected value. So in that case, what is the best option is that you take the 50%. But if you expect that it is a rare disease or if it is a very common disease, in that case, 50% is not suitable for that. That is 10%, less than 10%, 10 or less than 10%, 90 or more than 90%. So that you take care about when, if you are taking the 50%, generally you find the in literature that we are not able to find, we are taking the 50%. So that is acceptable, but that you should aware that it should not be less than 10%. If that less than 10%, your result will be wrong for that. Because in that case, margin of error is your margin of error. You have to take less margin of error. So this is all about the estimation of the proportion. Now, up to this, we have calculated the sample size. What are the adjustment for the prevalence form? What a need for the adjustment? There are some adjustments are required. First adjustment is a continuity correction. Is that this applicable only in the case of the categorical variable proportion. What is that continuity correction? Continuity correction is that when you are calculating the proportion, you are finding out and plotting this proportion into this type of sampling distribution. So this histogram is there. And we are assuming that our data distribution is a normal distribution. That is a continuous distribution. So our histogram is not continuity. To make this as a normal, we do this a continuity correction. In continuity correction, our sample size will increase. We have to apply some continuity correction. There are some complex formulas are there. So I am not explaining that complex formula, but from the software, I will explain continuity correction is there. But if your formula, I take the difficult to understand that, but you understand what is the meaning of the continuity correction. Continuity correction, I am again repeating that if you are, this is applicable only in the case of the dichotomous variable proportion, because if you plot the distribution, that is a binomial distribution based on that is discrete distribution, and we are converting into the normal distribution, that is a continuous distribution. So that is a called continuity correction. To discrete distribution to make continuous, there is a continuity correction. Another is correction is a finite population correction. What is the meaning of the finite population correction? I will explain in the next slide for this one. This is the finite population adjustment is there. What is the meaning of that? This sample size is calculating on the basis of assuming that we have an infinite number of subjects. So if you have a sample target population, have a restricted subjects. Restricted subjects means is that you have a total population is 1,000 subjects. So what you have to do? What is the example for that? This is the example. A researcher wished to estimate the prevalence of hypertension in an age of greater than 40 in a Delhi urban area. From previous study, he found that the prevalence is 40%, considering that all these things are there. But now is that what is the sample size if the area population is 1,000? He is taking some area that is only have a 10,000 population. So whether the 10,000 population will affect on that infinite, if you are calculating from the infinite, if there is only 1,000 subjects are there, then it will be the target population. This is the 1,000 is the target population. So whether it will affect. So I have calculated the sample size from the making infinite, that is called for 144. If I take using first I explain this one, this formula is for that n0 multiplied by n. This is my target population number. This is my sample size calculation from using infinite, and using this formula I calculate the new sample size, that is the finite population adjusted. So I have calculated sample size from 144. Now, if I took the 10,000 as my target population, then my new sample size will be 144 multiplied by 10,000 divided by 144 multiplied by 10,000 minus 1. That comes to be 142. So in that case, there is not much difference is that 144 and 142. So what we have, the only two number of cases are different. But if I have a 1000 of target population, my sample size reduced to the 144 to the 126. So in that case, there is a finite population adjustment. But if a target population is higher, then there is a no need for adjustment. But if you see that, find out that the target population is lesser, then you can calculate the sample size taking this target population. This is called the finite population adjustment. Now, another adjustment is that there is a generally in the survey that is a cluster or multi-staging sampling. These all the sample size are based on the simple random sampling. There are sampling method are there. Simple random sampling. What is the simple random sampling? Simple random sampling is that every subject in the target population is equal probability to select in the sample. So that means each of the person in target population have equal probability in the selecting in the sample, or systematic random sampling. That these formula are based on this one. But if you have some cluster sampling has a different than the random sampling. It has some benefits for that, but that I'm not going to explain. But you can see that, but only that cluster sampling. In cluster sampling, what is that? We found the standard deviation that is more than simple random sampling. So to adjust the cluster sampling, if you are doing the cluster sampling survey, in that case, you need the adjustment for the design effect. That is called design effect. This cluster is nowadays very much usually in the randomized control trial also, surveys also. So there is called a design effect. That adjustment is called design effect. What is the meaning of the design effect? Design effect is a variance in the other design divided by the variance in the simple random sampling. So generally in the other cluster sampling or some other sampling design, variance is more than the random sampling. So the design effect is greater than 1. But in the cluster sampling, you can find this formula to find out the what is the design effect value. In case of the cluster sampling, our sample size is equal to n, that is from the random sampling. This is called our design effect. But problem is here is that m is your cluster size, but intra-cluster correlation. This correlation is not usually available. So this is also a guesswork for that one. So generally, it is recommended that if you don't have any information for the interclass correlation, you can take design effect as a 1.5 to 2.0. So if you see the literature, then the immunization coverage cluster survey, there is survey is conducted for the immunization coverage, and they took the design effect as a 2. So what is the meaning of 2 is that whatever your sample size calculated to the random sampling, double of you have to take in the cluster sampling method. So this is the adjustment for the cluster sampling. Now, this is some other objects are there. What is the meaning of other objects? That I have explained already, that if you have a more than 2 or 3 objects are there, so you have to calculate the sample size for the each object, so object, and then you have to find out the what is the maximum sample size. In that case, you have to take. So maximum will be taken. So this is the cases for the multiple. If you are taking, finding out that proportion of the domestic prevalence, and it determines, and another is that the proportion of determinant domestic violence and determinant of, for example, a research planning to conduct a study for the determinants of the prevalence for the hypertension, diabetic, and both hypertension and diabetic. In that case, you have to take the for calculate the sample size for all this one, and then find out the what is the maximum. Then there is another type of objects are there. What another type of object is that there are the study based on that is a cross-sectional study. First, you find out the what is the prevalence, and then you are also going to find out for the what are the factor related this one. So the first is condition is that a researcher planning is to study a proportion of domestic violence. So first is the finding of that what is the domestic violence in 15 to reproductive women. in rural block of South India. So first objective is that. Second objective, he wants that it is what is the determinant, what are the factors that is influencing the domestic violence. So generally we found out in this prevalence study, first prevalence and then find out this one. If your objective is also for determinants, then you have to increase the sample size accordingly for that. So I will explain in the further slides this objective, prevalence and other objective by taking the first literature examples also. Now this is up to the mean and standard deviation. And now we come to the estimation of the correlation with a specified margin. So what is the correlation? All you are, I think, aware about the what is the meaning of the correlation. Correlation, there are two type of correlation, Pearson correlation and Spearman correlation. Pearson correlation is a parametric correlation. Spearman correlation is a non-parametric correlation. Some assumptions are there. So that I am not to be discussed here, but our objective is to find out if you are finding the correlation study. So you have to find out the sample size based on the correlation. So this Pearson correlation provide the strength of linear association between the two quantitative variables. The first is the strength of this variation is varying from the -1 to +1. And this is the formula for calculating the sample size for the estimation. This is also same. This is our normal variant. This is somehow R. This is the margin of error +1. So same format is there for calculating the sample size. R is the anticipated correlation. What is the anticipated correlation? This anticipated correlation we don't know, but we want to estimate that one. This correlation we take from the previous study, pilot study or expert opinion. What is that? What our source is that you have to for anticipated correlation. Then D is a desired precision, either the side. What are the desired precision you have to take for this? How much correlation plus minus you are acceptable for this one. So I am taking one example how you can calculate the correlation. The investigator planned the correlation study to find the correlation between the physical fitness test score and comeback fitness score test for the army person. So there are two type of score. We are finding the correlation for the fitness. Anticipated correlation is 0.5 between these two variables. The anticipated is 0.5. How much sample size is needed with the absolute margin of error of I1 on either the side with 95% confidence interval. So I am putting this value Z alpha is equal to 1.9 square, 1.96 square, 1.96 square is equal to 3.84. Here I have not written this one 1.96 square, but the square is 1.96 square, that is 3.846. Multiply by 1 minus anticipated correlation square to whole square divided by your desired precision +1. That comes to be 218. So that is 218 subjects are required for finding the anticipated correlation of 0.5 with a precision with a 0.5 with 95% confidence level. So this is the example for the finding out the correlation with a specified margin. This is the another example that I am not going to be explaining. The same thing is that because the time I think is not shortage of the time is that. So now we come to this point is that what is the diagnostic study? How we calculate the sample size for the diagnostic study sensitivity specificity. So this is the sensitivity specificity. What is the meaning of the sensitivity specificity and what are the study design in the sensitivity specificity is that first is that case control versus cross-sectional, that is proposed design. There are two type of study design. First is the case control. In case control, we already know about the case and control. This design is not much oftenly used in the finding out the diagnostic study, but in some scenario we are using that. What scenario is that? Suppose in pathology, we already have a slide for that biopsy, and somebody others want to find out some biomarker on the slide. So in that case, we are known about the malignancy is there or not malignancy, and we find out whatever the biomarker. So in that case, the gold standard we are not going to be applying. We know that this is a malignant subject or this is non-malignant subject. So that case and control study is applicable in that scenario. But most of the scenario in that this is cross-sectional, we simultaneously apply the gold standard to the and new diagnostic test to the suspected cases. Now here, what is the meaning of the suspected cases? Because the suspected cases is much influence on the sample sizes. Suspected cases, that cases who are subjected for the disease. Those healthy are we are not taking. Whatever the suspected, suppose we are taking for the cancer. So those are the you are technician. Doctor, according to the symptom, suspect that it may have cancer. So that is called suspected. Or in orthopedics, a doctor may suspect that there is a hairline fracture. So he will ask for the X-ray or for this one. So that is a suspected cases for this one. So these suspected cases, why I'm saying because it has a much role in finding out the sample size for the sensitivity and specificity. So you must aware what is the suspected cases. So this is, I'm skipping that one, the pair and unpaired design is there. That is the, this is just about the sensitivity, specificity design. Now, what is the sensitivity and specificity? And sensitivity, sensitivity is a probability of having test positive result among the disease positive. In that case, we know about the disease. We find out whether from the new test, whether how much proportion is there. The probability of having test positive result among the disease positive. We know the disease positive from our gold standard, and our diagnostic test is that is a new test. And sensitivity is that probability of having test negative among the disease negative. So we have a two disease positive and disease negative subjects. So in case control study, we disease positive take or disease negative take. But if we have a cross-sectional study, in that case, we don't know about the what is the case disease positive and what is the disease negative. So we find out based on the suspected case proportion. Here the proportion in the suspected cases. So next slide, I will explain from this is the sample size calculation for the sensitivity specificity with a given precision. So the first formula is similar from the estimation. Estimation is that this is our Z alpha by 2. I have not taken 1 minus alpha by 2 and 1 minus alpha by 2. That is the same values are there. So multiply by the sensitivity, multiply by 1 minus sensitivity divided by what is the margin of error is acceptable for the sensitivity specificity. So same as a like in proportion we are doing here for the sensitivity and specificity. But point is that what if we are calculating this for the sensitivity specificity, this sample size will give the what are the total number of disease patient is required. You have to take care about that. This sensitivity specificity calculation is give the number of subject that is required in the disease subject. This is non-disease subject. So how we calculate this one? For if your sensitivity is important, you are calculating based on the sensitivity only. So total sample size of sensitivity is equal to number of disease subject required divided by prevalence. Now this prevalence is on the suspected subjects. This prevalence is not in the population. This you have to take care about that. I am just repeating because the most of the error come here. Generally, people will take the general population, which is very less for this one. That you have to take this prevalence into the suspected subjects. Okay, because you are going to be calculated from the disease and disease from the suspected subjects are there. So how much disease subject is required from the suspected subject? This calculation will give this total number of subject in case of the sensitivity. So prevalence is again, I am repeating, this is from the suspected subjects, those who are subjected to the disease, not for the general population. Same thing we apply for the specificity is there. So specificity give the number of subject for the non-disease. Here, if you apply the subject, it will give the non-disease subjects. And total number of subjects you can get from the non-disease divided by 1 minus prevalence of that. So this is for the sensitivity and specificity. If you find the sensitivity is important for your study, you calculate the sample size based on the specificity. If your specificity is important, you calculate the based on the specificity. If both are important, generally both are important, because the diagnostic test is sensitive also or specific also. So in that case, both are important. In that case, you calculate the sample size on the based on the sensitivity also, specificity also, and whatever the maximum sample size is there, that sample size you will take for the study. So this is all about the sensitivity and specificity. This example I am taking that from the previous literature shows that the CT has 85% sensitivity and 90% specificity in a diagnostic of a prostate cancer in a male gender that is a 60 years of the age. So this is our CT diagnose the prostate cancer, 85% sensitivity and 90% our specificity is there. Now gold standard is histopathology, and both sensitivity and specificity are equally important for that. So determine the sample size with a 5% margin of error on the either the side with 95% confidence level with prostate proportion of prostate cancer in suspected cases, whatever is 40%. So whatever the male subjects are coming to the hospital and that is suspected to the prostate cancer. They may have some urine problem is there, some they have blood in urine, or some suspected subjects. In that case, is 40% is that 40% maybe is malignant for that. So that using this information, first I use this formula for finding out the total number of disease based on the 85% sensitivity. I have calculated this. The sample size is 1.96 or 196, and on what assuming the proportion of suspected cases 40%, my sample size is required 490. 490 subjects is required. Why 490? 490 subjects is required so that I will get at least 196 disease subject. So my aim is, what is the aim for dividing this? Aim is dividing is that I will get at least 190 subjects for calculating the sensitivity. Same thing in specificity, I found that non-disease subjects are 139, and if I divide it by 1 minus 0.05, sample size will come 238. So if specificity is important, so I will get 232 subjects so that I will get 139 non-disease subjects. But here we have both are important. In case both are important, so we'll go for the 490 subjects to accommodate both sensitivity and specificity also. So these are some things are there. Some large sample size is needed that I have already explained in that. The variation is more than you have a large sample size, confidence level is high, large sample size requires precision is there, high sample size are there. So these are already I have explained. So I am skipping that simple this one. Now this thing I have to mention here that the relationship of prevalence and multivariable analysis that I have already explained, but this is example I am taking for much clearance of that. A prevalence study are accompanied by a research for associated predictors or the risk factors of the prevalence outcome variable. If the objective is not only to estimate the prevalence, but also to identify the predictors or associated factors, it is advisable to inflate the sample size accordingly. So in that case, I am taking one example. For example, a subject is to determine the prevalence of impotence among the type 2 diabetic patient visiting an endocrinology department as well as to assess the associated risk factor. So investigator find that sample size is 250 is subject on the find based on the impotency prevalence 20% and 5% absolute margin and 95% confidence level. So he calculated that that sample size is 250. But apart from that, he also collect the 15 plausible risk factor for that. What is that? He is what क्योंकि objective is to find out the factors for the impotence. So he from the literature he found out that the 15 factors are there. So he collect the information of the 15 plausible factor also. So whether these 250 subjects are quite good for accommodate this 15 risk factor. So based on the proportion, if I take the proportion of sample size of 250 and the prevalence is 20%, so I have only the 50 subject of impotence one. Out of 20 subject, 200 are non-important. So this is not adequate for taking the 15 plausible risk factors. So what we do, we increase the sample size by using some rule of thumb. That rule of thumb is for logistic, okay? Because here we are applying to be logistic regression to find out the what are the risk factors. So a rule of thumb for the logistic regression is at least 5 to 10 subject per variable for the minimum outcome. Our minimum outcome is here impotency. So we need at least 5 to 10 subject, or if you take the 5, in that case you need the 75 impotent subject to get in accommodate this 15 plausible risk factor. But for the safer side, I will recommend for the go for the 10. That means you need for the 150 impotent subject to accommodate risk factor. So these are the basic problems are coming when you are doing this one. You calculate the sample size, but later you find out the risk factor. That risk factor for risk factor logistic regression or other multivariable you are applying, that is not found feasible for this sample size due to the small sample size. In that case, what you do, you cannot apply logistic regression, or if you are applying the logistic regression, you are got the wider confidence intervals, that is not reliable for this. So in designing phase, you have to take care in the prevalence studies for this. So this is some literature example I have taken, but the time is over, so I am skipping that one. So only one I explained that one, the prevalence and risk factor of antibiotic utilization in the Chinese children. So this is they are finding out the prevalence also or risk factor also. So in that case, they have to adjust for this one because they have taken the large number of studies, so their sample size is not problem. But if you have to calculating the sample size on the prevalence, so you should adjust the risk factors accordingly, risk allowances for the risk factors. Now this is how I think maybe what are the mode for getting the sample size, how you can calculate the sample size. There are various methods for calculating the sample size. First is the manually calculate. Whatever the formula I have given, you can calculate the manual calculation. But problem in manual calculation is that there's some calculation error may be there. So I will suggest whenever you are going to calculate the manual calculation, you should verify with the online calculator whether it is coming similar or some maybe differences there. There are some nomograms are there. Some nomogram there is a pictorial diagrams are there. So you can find out from the diagram what are the required sample sizes needed for this one. So using some tables, lot of tables are available for that one. So this is the one example is this is SK Langewala. That is a lot of tables are available under the different scenario for that. So you can use for that. Another is that use of online application. There are various online applications are available. That is OpenEye, Seal, envelope calculator, statulator. That I am using a statulator. So maybe tomorrow first I will explain how you will find out these to the statulator. Then we go for the hypothesis testing and use of sample size software. So there are a lot of softwares are available. That is commercial software that pass is available, and master this is available. There are some free software, but some paid software are there. my precaution, the caution is that the sample size calculation are prone to error. There are so many are prone to error because what error is that they are based on formula, are based on some assumption. They are some software using some online calculator using some assumption, other using another assumption. So before using the sample size calculator, you should check whether you are correct for the assumption or not. Even with the software, it is usually good practice to verify these calculation by experienced person in the field. So you can verify this sample size calculation with a statistician or some epidemiologist whether my calculation are correct or not. So these are the some modes for getting the sample size for the study. Now the major problem is coming is that how to report that. So this sample size, this is the template. The what is the I am just making the template how to report the sample size. In case of the proportion, you report the sample size that from the previous study reported the proportion of disease range from the 20 to 30. So in that case, there may be a single proportion also or may range be, also. So first you have to report that from target population, what are the expected target from where you have to determine it. And if their range is there, then what you are taking the expected. So expected 30% proportion disease in the present study population at a margin of error, 5% margin of error on the either side. I have not written absolute here, but if you are taking absolute, so you should also write the 5% absolute margin of error on either the side with 95% level. We require a sample size of this subject is there. This is without continuity correction. Whatever the adjustment or correction you are using, you should report that. If you are using continuity correction, if you are using finite population correction, if you are using cluster sampling correction, so that correction you'll be non-response also. So whatever adding, you are inflating the sample size by using some adjustment or some correction, you should report in the sample size paragraph in the text. If the word limitation is there, that you can take the supplementary material, but you should report in a correct way so that what is that so that the reader can recalculate or understand the how you calculate the sample size. And lastly, what source you have calculated in the sample size, whether you are calculating the sample size from the package. If you are calculating the package, you report that package name, or if you are using the formula. So generally formula manuscripts are not accepting that, so you can give in the supplementary or material, or just write the package or online calculator. So this is all about the proportion. Same thing for the mean, you have to report what from the where you have taken the standard deviation. You report the reference of this, what are your margin of error is there, what is your adjustments are there, what for package you are using, or online calculator you are using. So this is the template is there, that is should be reported. There are a lot of errors are there, and as a reviewer I found that there is a lot of missing information there. Some miss the margin of error, some miss the confidence level, some miss the this one type 1 error in hypothesis testing. So that you have to take care about the reporting of that. Whatever you have calculated, that reporter should recalculate this one. So now this is all about the estimation, and this is the just brief of that. The take home message is that the precision-based approach sample size estimation assume the sample random sampling, infinite population, and normality of the sampling distribution. So these three assumptions are there on the precision base. If any of the assumption violated, adjustment is needed and calculated sample size would be higher. So in that case, other there is a violate infinite, not violating is there no, but if you need the adjustment, in that case your sample size will be higher. This approach does not apply for the hypothesis testing. Hypothesis testing, this you cannot apply for. If your objective is for hypothesis testing, you cannot calculate the sample size based on the estimation. The main key factor in the case of population mean estimation, standard deviation, margin of error, and confidence level. Caution is required while calculating the sample size using online calculator based on absolute or relative, and large sample size would be required for the heterogeneous population. required higher precision and the greater confidence level. Estimation of the prevalence or proportion, we need the expected value of the proportion, and this for the form where we can get from the previous literature, pilot study, experience, or some meta-analysis. The commonly used study design for the sensitivity and specificity is cross-sectional, and we need to the expected prevalence in the disease, that is the suspected cases, expected prevalence of disease in the, that is a suspected prevalence. So that you should need for the calculating for the sensitivity, specificity. Generally, people but they calculate the sample size on the base of the sensitivity. They don't know about that this is for the disease patient only, and then they do the study. But later on, they found that there is only for the disease patient. They have not added the non-disease patient. So that should take care about that. That is divided by the prevalence of the disease in the suspected cases. Report all the key factors used in the sample size calculation so that the reader or reviewer can verify them. Whatever your parameter you are using for the calculation of the sample size, you should report in the paragraph, the template I have given in that case, so that reviewer or reader can verify this one. So these are the some example for this nomogram and table. And now this is the practical example. I think tomorrow I will take for the practical example using the statulator or some another software. We will discuss first how to calculate the sample size for this one using calculator. And this is all about the thank you for your kind attention and listening.